Two cars are driving on two perpendicular roads. Car A is approaching an intersection with a stop sign and is decelerating at a rate of 15 feet per second. Car B is driving away from the intersection at a rate of 30 feet per second. At what rate is the distance between these two cars changing when car A is 45 feet from the stop sign and car B is 60 feet from the stop sign? First, let's draw a picture. Since the roads are perpendicular, they intersect and form a right angle. Car A is heading towards the stop sign, the origin, which means that its velocity, 15, is negative. Since car B is moving away from the stop sign, it must have a positive velocity, 30. Let's also draw in C, the distance between the two cars, so we know what we're looking at. Next, we need to figure out what equation to solve the problem with. Since the picture looks like a right triangle, and you're given the length of two sides of it, it would be a good idea to use the Pythagorean theorem, a squared plus b squared equals c squared, for your beginning equation. Now that you know which equation to use, you need to take the derivative of it by reducing all the powers by 1, multiplying by the old power, and adding d variable over dt if t is not one of the variables. Do not fill in numbers until you are done taking the derivative, especially in this problem, since none of the numbers are constants. Once you have the derivative, it should read 2x dx over dt plus 2y dy over dt equals 2c dc over dt. However, before you solve, you need to find the distance of c when x is 60 and y is 45 by using the Pythagorean theorem. So you square 60, square 45, add them, take the square root, and you should get 75. Now that you have the derivative and all the necessary values, you are allowed to put in your values. For x, you put in 60, dx over dt is 30, y is 45, dy over dt is negative 15, the negative is very important, c is 75, and dc over dt we don't know yet. You eventually solve it down and it gets to 2,250 equals 150 dc over dt. To find dc over dt, you divide by 150 and you have the answer, 15. Since the rates from the beginning of the problem were in feet per second, this one should have the same label. So the rate of change of the distance between car A and car B at this moment is 15 feet per second.
I'm 15.